Welcome to In 5 Minutes. In this video clip, we will discuss the very first receiver which can be used to receive DSB-FC signal. The receiver is called tuned radio frequency receiver. We'll discuss the working of this receiver. It's very simple and very basic receiver. We will discuss mainly the drawbacks of the receiver because that will form the base for the next receiver. The drawbacks which we have in this TRF receiver are overcome in the design of the second receiver, which is called super heterodyne receiver. And super heterodyne receiver is the one which is used nowadays in many communication systems. So let's first start with the TRF receiver. We will quickly go through the block diagram and then we will discuss every block in detail and few more things. You can see there is an antenna to receive the incoming signal. The moment you receive the signal, it will be of very weak amplitude because the signal has traveled through the wireless channel from the transmitter side to the receiver side, during which it undergoes very high attenuation, and hence when you receive the signal, it will be greatly attenuated. Such a weak, very greatly attenuated signal cannot be given to the demodulator directly, and hence it will be first amplified. So you can see in the beginning itself we have series of RF amplifiers. We have shown two amplifiers. In practical circuit there might be more power amplifiers, there might be more amplifiers also. So this RF amplifiers will amplify the incoming signal so that it is of good enough amplitudes which is suitable to be given to the next block of demodulator. These amplifiers are called RF amplifiers because they have to amplify the received signal. Please remember that the received signal will be modulated signal because that is what is transmitted from the transmitter side. The modulated signal is always high frequency signal present around the carrier frequency FC. In case of double sideband full carrier, for which we are discussing this receiver as of now, the range of frequencies will be from FC minus FM to FC plus FM. So this will be the range of frequencies that will be received through the antenna into the circuit. So to amplify the radio frequencies, we need RF amplifiers. Now, the output of the last amplifier, once the signal is amplified with the minimum required amplitude levels, it is then given to detector block. Detector will carry out the reverse process of modulation, which is demodulation. So in simple words, the detector will take the modulated signal which is now amplified and it will somehow extract the original modulating signal from the modulated signal, and the modulating signal which is extracted is the output of the demodulation process. We will see the actual specific circuit that can be used in place of detector. It will be nothing but the envelope detector that we had very briefly discussed in one of the previous clips. So I'm calling the output of the detector as the modulating signal. We will see how this happens in detail in one of the later clips. So once we have the modulating signal as output of the detector, it is now again amplified through audio amplifier, because right now in the radio communication system, my modulating signal consists of the audio frequencies. It is then given to a power amplifier so that its power content can be increased, and it is then given to an output device which could be a speaker, which will generate the sound in the form of my final output signal. So you can see the entire receiver is very simple to understand. To summarize everything, the received signal is received through the antenna. It is amplified through series of amplifiers. It is then given to the detector block for demodulation. The output of the detector is modulating signal, which is amplified through audio amplifier and power amplifier and given to the output device in the form of a speaker.